Hi everyone, Mr. Lansing once again, and in this video we're going to talk about how to find the domain and range of the graphs of polynomial functions. Let us start by having a short review on the end behavior of the graphs of polynomial functions. So let's consider first odd degree polynomials. So based on our discussion last meeting, odd degree polynomials and their graph are either going up like this or going down like this. So take note, your hint whether the leading coefficient is positive or negative is to read the graph from left to right. So again, let's read the graph from left to right. So from left to right, our green graph is going up, so that should be positive, while our yellow graph from left to right is going down, so this must be a negative leading coefficient. So just to give you a general look of how the graph looks like, for odd degree positive leading coefficient, it should be going up like this, while for odd degree negative coefficient, since the coefficient is negative, the graph is decreasing or it's going down. So make use of that hint, whether it's going up or going down, to determine whether they have a positive leading coefficient or a negative leading coefficient. On the other hand, even degree polynomials are quite simple to understand. You just have to reconsider the graph of a quadratic function. So a quadratic function graph should be either opening up when the value of a is positive, and take note a is also our leading coefficient, and it is also opening down if the value of the leading coefficient is negative. Another hint that the graph is even is the direction of the arrows will be in the same direction. So the yellow graph is all pointing down, while our blue graph is all pointing up. Okay, so in this scenario, if we were going to simplify and rewrite it here, for even degree polynomials and a positive lead coefficient or leading coefficient, the graph should be directed up, while an even degree polynomial with, this is a negative coefficient, is going down. Okay, so again, this is a negative leading coefficient. So just to make sure that you understand this, so for odd degree polynomials, it's either going up or going down from left to right. And make sure that you also understand that the arrows will be pointing in different directions. And for even degree polynomials, it's also pointing up or pointing down depending on the leading coefficient, but the only way to differentiate whether it's even from odd is the arrows are directed in the same direction. So take note of that and make sure that you understand that, because that will be useful in understanding domain and range. Let us consider this graph in front of us this time. This is a graph of an odd degree polynomial and with a positive leading coefficient, because the graph is going up from left to right. So I want you to take a look closely into our domain. So when you say domain, these are the x values that the graph can use. So let's consider going to the left and going to the right. Are there any restrictions for the graph in going to the left and the right side of this rectangular plane? So take note that this arrow continues to go down and gradually moves to the left side, and this arrow continues to move up and gradually moves to the right side. Is there a point where the graph cannot go? So if there is no point or areas where the graph are restricted, then our domain should be negative infinity, comma, positive infinity. We're going to read the graph from left to right for our domain. This time, let's go to the range. Okay, range is the y values. So this time I'm going to use another color so that we can differentiate. So the graph range is going down and going up. Okay, so from the bottom up, do we have a limitation for the graph that it can go into a specific y value at the bottom? Do we also have a limitation for the graph to go up? So if there are no limitations, then our range will be negative infinity, comma, positive infinity. Okay, so take note that the graph continues to go down and continue to go up using all the x values or y values down and y values up. So the domain and range of this type of function is negative infinity, positive infinity. Take note, this is for odd degree polynomial with positive lead coefficient. Let us consider another example of an odd degree polynomial, but this time with a negative lead coefficient. That's where the graph is going down from left to right. Okay, so let's take a look whether you can understand this time how to find our domain. So domain of the function is from left to right, x values. Do we have a limit or limitation in going to the left and in going to the right? If there are no limitations, then it's negative infinity, comma, positive infinity. For our range, so from the bottom of the graph, and we're going up, is there any point that the graph is restricted in going down and in going up? So if there are no restrictions, this time our range is also negative infinity, comma, positive infinity. To summarize things up, when we're dealing with odd degree polynomials, whether it's having a positive or a negative lead coefficient. For example, this one here, the graph goes up like this, and this one, the graph goes down like this. Our domain and range will always be the same. So negative infinity, comma, infinity for our domain. Our range is also negative infinity, comma, positive infinity, because there are no restrictions both in the left side of the x-axis and the right side of the x-axis. Our range is also without limitation or without hindrances. So we are going to also write negative infinity, comma, positive infinity, and negative infinity, comma, positive infinity. And this is true to all odd degree polynomials, whether they are having a positive leading coefficient or negative leading coefficient. Domain and range will always be constant like this. How about even degree polynomials? So let's consider this example. This is an even degree because the graph's arrows are pointing in the same direction. So both are pointing up. Okay, so it's even degree and it's positive leading coefficient. Let's take a look closely whether you can identify this time our domain. So our domain from left to right. So is there any restriction from left to right? So left and right, there are no limits or no limitations. So it's negative infinity, positive infinity. This time, our range is from the bottom of the graph going up. And range is the collection of y values. Okay, in this example, our range from the bottom has a limit, and its limit is -1. And since -1 is part of the collection, we're going to make use of a bracket to enclose -1. So we have here -1, comma. So take note that from the bottom, the lowest y value is -1. So we're going to move up, and what values are there as we move up? These are positive infinity. Enclose it with a parenthesis. So again, for graphs opening up, even degree polynomials with positive leading coefficient, look for the lowest value of y, and you can find that by actually using your Desmos calculator. Let us consider another example of an even degree polynomial with a negative leading coefficient. That is why the graph is pointing down. So take note closely that in this example, we are also going to consider whether we can find our domain correctly. So domain, so is the graph limited in going left or right? As the graph goes farther down, there is no limitation for the domain, so it's negative infinity, comma, positive infinity. Okay, how about our range? Do we have a limit from the bottom? So our range, starting from the lower portion of the graph, has no limitations. It uses everything down there. So it uses negative infinity. But as we move up, take note that there is a limitation here. Okay, so the y value of this point is your limitations. In this case, we will approximate 1. This is maybe 1.6, and it's part of the collection. Okay, so I hope that this explains. Okay, so take note closely into what happened here. Our domain is the same, negative infinity, positive infinity, no restrictions left and right, but our range is different. From the bottom, we are using everything, every y values, and when we move up, our last y value is 1.6. It's only an approximation, but if you're using your Desmos calculator, you can find the exact value for y to put there. To give us a short summary then, for an even degree polynomial with positive and negative leading coefficients. So let's take a look at how the graph looks like. It's going up for this because they are having positive lead coefficient. This one goes down because they have a negative lead coefficient. So our domain for both cases of the even degree polynomial will always be negative infinity, positive infinity. So take note, there are no limitations in going left and right, but our range is something that changes. So take note that in this case, you will always start from the bottom part of the graph, which means that bracket, you are going to find what is the lowest y value, and you're going to use the local minimum paired with positive infinity because we're using all the values going up. In this case, or the second case for even degree negative leading coefficient, you will always start from the bottom of the graph, that's negative infinity, all the values that are used, and then the partner for this is your highest y value, and you can find that by looking at the local maximum of that given function. I hope that this helps in understanding domain and range. Prepare your questions for the live lesson.